Welcome to qnawire.
In this problem, we've defined the centripetal force and the tension needed for a monkey to swing by its arm from a branch. And we're given first that the radius of the monkey's motion is equal to 85 centimeters, and we should be careful to rewrite that as 0.85 meters, because remember, we're always working in units of meters, kilograms, and seconds. The velocity of the monkey is 2.8 meters per second, and its mass is 9.5 kilograms. The first part of the problem is just to find the centripetal force, which we know is given by the following equation, mv squared over r. All we have to do, since those are all known quantities, is start plugging in. So we have 9.5 kilograms, 2.8 meters per second squared, all over 0.85 meters. And when we solve that, that is going to be equal to roughly, after we round, 88. And the units that we're going to get are kilograms meters per second squared, which is just equal to newtons, which makes sense since that's the unit of force. So we know that our answer is right, 88 newtons. That's what our centripetal force. All right, now we can do part B. Here, we have to find the tension on the monkey's arm. Now, if we draw a free body diagram for the situation, right, we have, if this is our arm, and this is the circle that the monkey is moving in, the force of tension, when we draw our FBD, is pointing like this, and FG is pointing down here. Now, T has two components, right? Let's draw it in more detail down here. A Y component and an X component. Now, the y component must be canceling out the force of gravity, right, in order for the monkey to not fall. So ty must be equal to fg. And since we need a force to be responsible for our centripetal force, tx must be equal to fc, which equals mv squared over r. Now, since t is just equal to tx plus ty, all we have to do is plug in our answers from before to find that t is equal to mg plus mv squared for r. And when we plug in our quantities, let's see if I have enough room. 9.5 kilograms times 9.8 meters per second squared plus 9.5 kilograms times our velocity, 2.8 squared over our radius, 0.85 meters. I know I'm missing my units for velocity, but ran out of room. Imagine that they're there. We plug in, we get that we have units of 181 kilograms times meters per second squared. And once again, that is just equal to newtons, so we know that our answer makes sense since newtons are the units of force. So our answer to part B is that T is equal to 181 newtons.